Welcome to Controls and Signals, part of the Fire Alarm and Signaling System Fundamentals online learning series from NFPA. Click Next to get started. This learning series covers a range of topics related to fire alarm and signaling systems. By the end of this lesson, you should be able to describe the role of a control unit in a fire alarm and signaling system, describe the role of circuits in control unit inputs and outputs, and define and differentiate common types of fire alarm signals, conventional and addressable fire alarm and signaling equipment, and circuits in a fire alarm and signaling system. The menu bar at the top of the window provides important functions to help you as you complete this lesson. Select Menu to see an outline of the lesson that displays your progress. Navigation provides instructions for navigating this lesson. If you need to close the lesson, select Exit to leave and save your progress. Select the collapse menu icon on the left to show and hide the transcript. This lesson includes knowledge checks and short activities designed to assess and apply your learning along the way. What do you think? Questions give you a chance to think about a topic before we discuss it. Activities ask you to apply what you've learned in a practical scenario. There will be a 10-question assessment at the end of the lesson. You must achieve a passing score to complete this lesson. Remember that what do you think and activity questions are not graded and will not affect your final score. This lesson will be broken down into 3 sections. First, we'll start by mapping a fire alarm and signaling system, focusing on the fire alarm control unit and the signals that it sends and receives. Then, we'll put the system to use, focusing on basic types of alarms and system equipment. After that, you'll go through a short activity to apply the information you've learned in the first 2 sections. This lesson should take about 30 minutes to complete. Click Next when you're ready to proceed. Let's start by taking a high-level look at a basic fire alarm and signaling system. Initiating devices send signals to provide the status of a protected space or the existence of a fire. Other building equipment is also supervised by the fire alarm and signaling system to ensure that it will function effectively in an emergency. Notification appliances are used to alert occupants to relocate or evacuate in the event of an emergency. Primary and secondary power supplies provide uninterrupted power to a fire alarm and signaling system. These systems also control other functions within a building in the event of an emergency, and communicate to emergency services and more through off-premises signaling. But how do these systems all interact and communicate with each other? These systems all interact through the Fire Alarm Control Unit, or FACU. Some may also refer to it as a fire alarm control panel or fire alarm panel. Here's an easy way to think about it. The fire alarm control unit is the brain of the system. The component systems are the body and limbs. In the human body, the brain sends signals through the nervous system to control the limbs. The fire alarm control unit sends signals through a system of circuits in a building to do the same thing. A circuit is a means of providing power or a connection path between locations. The equipment throughout a fire alarm and signaling system operates on specialized circuits. For example, notification appliances receive signals from the fire alarm control unit through a notification appliance circuit, or NAC. Emergency control functions are implemented through a control circuit, or a signaling line circuit, or SLC. Initiating devices send signals to the fire alarm control unit through either an initiating device circuit, or IDC, or an SLC. We'll discuss the difference between initiating device circuits and signaling line circuits later in this lesson when we look at conventional and addressable fire alarm and signaling systems. For now, just remember that circuits run throughout a fire alarm and signaling system, and different circuit types are used for different equipment. Let's see how this works through a common sequence of events. An initiating device, in this case a smoke detector, sends a signal to a fire alarm control unit, alerting it to the presence of smoke in that area of the building. The fire alarm control unit processes this information and begins sending signals out to other systems and equipment according to its program. That equipment includes notification appliances throughout the building, which start to alert occupants to the danger. Even if the smoke detector and notification appliance are next to each other, they still communicate through the fire alarm control unit. We've already defined circuits as they relate to fire alarm and signaling systems, but now we need to define the signals that are sent through them. Equipment in a fire alarm and signaling system either sends signals as an input to a fire alarm control unit or receives signals as an output from the fire alarm control unit. Throughout this lesson and learning series, we'll be referring to inputs and outputs. Defining signals as one or the other is central to the functioning of a fire alarm and signaling system. Let's focus on the idea of inputs and outputs in a system a bit more. What do you think? Which of these examples of fire alarm and signaling system equipment sends signals as an input through circuits to a fire alarm control unit? Select all that apply, then click Submit. That's correct. Heat and smoke detectors both function by sending signals as an input to a fire alarm control unit, whereas alarm equipment like strobes and speakers receive signals sent as an output from the fire alarm control unit. What about more equipment that receives signals sent as an output from a fire alarm control unit? What do you think? Which of these examples of equipment receive signals as an output through circuits from the fire alarm control unit? Select all that you think apply. That's correct. Like heat and smoke detectors, pull stations and carbon monoxide detectors send signals as an input, while smoke control and off-premises signaling equipment both receive signals sent as an output from a fire alarm control unit. Before we move on, remember this: the way specific devices function in a fire alarm and signaling system is important, but it's not essential to the basic concept of inputs and outputs in the system. Designers might choose a particular type of initiating device to be installed throughout a building, but they'll still send signals through circuits to a fire alarm control unit as an input. And it doesn't matter if they choose to design a system with the minimum number of notification appliances or far exceed local requirements. The fire alarm control unit will be programmed to send signals through circuits to them all as an output. Now that you've seen the role that circuits play in a fire alarm and signaling system, we can start to dive deeper into the different ways that these systems work by putting the system to use. In this section, we'll look at the three basic types of conditions that can be observed at a fire alarm control unit: alarm, trouble, and supervisory, and conventional and addressable fire alarm and signaling systems and equipment. Once a fire alarm and signaling system is functioning in a building, there are limitless combinations of inputs and outputs that can be sent to and from the fire alarm control unit. But to bring some order to these signals, there are three basic conditions that trigger them. These are alarm conditions, trouble conditions, and supervisory conditions. Click Next, and we can dive into each. An alarm condition exists when there's an immediate threat to life, property, or mission. You saw the example before about an activated smoke detector sending a signal to a fire alarm control unit, which then triggered notification appliances to alert occupants. Because there are active signs of a fire, this would be an alarm condition. A trouble condition exists when there's an issue or fault with the fire alarm and signaling system. Imagine that a break occurs in an initiating device circuit. Because of the break, if a fire were to occur, any initiating devices on the circuit wouldn't be able to send a signal to the fire alarm control unit. If a fire alarm control unit detects this break in the circuit, it would appear as a trouble signal, giving maintenance personnel the opportunity to fix the problem. Like a trouble condition, a supervisory condition exists when there's a detectable problem with a system, process, or equipment in a building. The difference is that while a trouble condition relates to equipment that's part of a fire alarm and signaling system, a supervisory condition relates to components that aren't part of a system but are monitored or supervised by the system. An example of this would be an unintentionally closed valve in a building's sprinkler system, which is supervised by the fire alarm and signaling system. When detected, this would appear as a supervisory signal on the fire alarm control unit, again allowing maintenance personnel to address the issue. The type of condition created is not dictated by the device. Instead, it's determined in the programming of the fire alarm control unit. In some cases, the activation of a device supervising another system, such as a kitchen suppression system, may create either a supervisory condition or an alarm condition. This is based on discussions between the owner, designer, and authority having jurisdiction, or AHJ. What do you think? If a malfunction were detected in a notification appliance circuit controlling strobe lights in one section of a building, what kind of condition would be triggered in the fire alarm control unit? That's correct. Because the strobe lights are notification appliances and part of the fire alarm and signaling system, a detected malfunction would trigger a trouble signal at the fire alarm control unit. Next, we need to look at the difference between conventional and addressable fire alarm and signaling system equipment. To explore the difference, let's look at two different buildings. Each has its own fire alarm and signaling system, with each using one of two different methods for signals to be sent to a fire alarm control unit. In the first building, the fire alarm and signaling system is monitoring initiating devices on every floor. All devices on the same floor are connected to the same circuit, or zone. Each circuit is being monitored by the fire alarm control unit. If any of these devices are activated, they'll act as a switch and cause the entire circuit to go into alarm. However, the control unit won't know which specific initiating device caused the circuit to go into alarm. Additionally, because it's acting as a switch, the initiating device can only provide very basic information by making the circuit normal or activated. This is a conventional system. In the second building, the fire alarm and signaling system is also monitoring initiating devices on every floor. But here, the fire alarm control unit doesn't use the circuit to determine the location of the alarm. Instead, each initiating device is assigned a unique identifier that it uses when it sends a signal to the fire alarm control unit. The signal may still be basic, normal, or activated, but the unique identifier provides its specific location. This is an addressable system. There's a category of addressable fire alarm and signaling system equipment that's also important to remember: analog addressable equipment. Like standard addressable equipment, analog addressable equipment provides a signal with a unique identifier to the fire alarm control unit. But unlike standard addressable equipment, it can also provide additional information beyond normal and activated. For example, an analog addressable smoke detector can also provide the percent obscuration of the smoke, which allows the alarm threshold to be determined at the control unit instead of at the initiating device. There are two important things to remember about conventional and addressable systems. First, they use different types of circuits. In the previous example, we discussed initiating devices. In a conventional system, these devices would be on an initiating device circuit, or IDC. In an addressable system, a signaling line circuit, or SLC, would be used instead. Both circuit types transmit signals as an input to a fire alarm control unit, but differ in the way they transmit those signals. Second, locally enforced codes don't require one type of system over the other. Instead, it's the choice of the owners and designers to choose the system and make it compliant. Now that you've explored alarm, trouble, and supervisory conditions, and the difference between conventional and addressable systems, it's time to go through a short activity to apply what you've learned. In this activity, we'll show you two buildings, each with its own fire alarm and signaling system. We'll describe aspects of the systems and the signals that are sent into and out of the fire alarm control units. We'll ask you questions along the way. Click Next to get started. The first building, Building A, is 4 stories tall and mostly rented office space. The fire alarm control unit is located on the first floor. The building's owners staff the building with personnel to monitor the entire fire alarm and signaling system. A heat detector on the 3rd floor has been triggered by heat in the immediate area. What type of signal would this? That's correct. This event would send an alarm signal to the fire alarm control unit. The fire alarm control unit displays that the 3rd floor zone is in alarm. There is no way for the staff to determine which device caused the alarm. What kind of system does this building have? That's correct. Because the fire alarm control unit can only provide the zone that contains the specific heat detector, this must be a conventional system. What type of circuit connects the 3rd floor heat detector zone to the fire alarm control unit? Remember, we already know that this is a conventional system. That's correct. Conventional systems use an initiating device circuit, or IDC, to connect to initiating devices. The second building, Building B, is a 5-floor hotel. It also has a full fire alarm and signaling system, with a fire alarm control unit on the 1st floor. The system is monitored by employees of the property management company that owns the building. One day, the fire alarm control unit detects that there's been some kind of break in the notification appliance circuit that controls the notification appliances on the 5th floor. If a fire were to occur, the system wouldn't be able to alert the 5th floor guests. What kind of condition is this? That's correct. Because the fire alarm control unit has specifically detected an issue with equipment that's part of the fire alarm and signaling system, this would be considered a trouble condition. A week after fixing the notification appliance circuit, the fire alarm control unit reports an alarm condition from a smoke detector in the living room of guest room 402. After receiving the signal, building staff dispatch help to that room. What kind of system is this? That's correct. Because this system can determine the specific location of initiating devices, this must be an addressable system. When the fire alarm control unit determined that there was an alarm condition in guest room 402, it did so because the smoke detector reported smoke obscuration that was above 3%. That percentage of smoke density was programmed into the fire alarm control unit. What kind of device is this smoke detector? That's correct. Because the smoke detector can provide its location, we know that it's an addressable device. But because it can also provide detailed information about the density of the smoke in the room, we know that this is an analog addressable device. Great job! You've completed this activity. Next, we'll wrap up this lesson and you can proceed to the assessment for this material. While the fire alarm control unit is the brain of a fire alarm and signaling system, it's the circuits that are the nervous system. This lesson should help you identify characteristics of the circuits and equipment in your own building. You should now be able to describe the role of a control unit in a fire alarm and signaling system. Describe the role of circuits in control unit inputs and outputs. Define and differentiate common types of fire alarm signals, conventional and addressable fire alarm and signaling equipment, and circuits in a fire alarm and signaling system. Thank you for your participation. You may now proceed to the assessment for this lesson. Now it's time to find out what you've learned. You'll be presented with a series of questions. A score of 70% or higher is required to pass. You'll have as many attempts as needed to obtain a passing grade. Note that there is no audio with the assessment questions. Select the next button when you're ready to begin. You have successfully finished the assessment. Once you complete the course evaluation, you will be awarded your certificate of completion with CEUs. You may now exit the module.